Hey guys, welcome back to my channel. I hope you're all well and safe. We are going to be doing a topic which you guys have been requesting for ages. I know you've been looking forward to this, and I am here to deliver. We're going to be doing transformations of functions. Okay, now here's an overview of the topic. We're going to look at function notation. That's what this video will be looking at. And then we're going to look at how we can use function notation to do transformations. So there's different types of transformations. Here are the different types you can get. So horizontal, vertical, reflection, and when you stretch or shrink a graph. And then once you can do those four things, where I'll explain why they work and how they work, we'll be applying those transformations to look at describing and sketching different graphs. So this video is going to be part one. So functions, recap, notations, and graph as well. Okay, so transformations, as you may have figured out from the last slide, is to do with moving graphs around. So translating means moving up and down, right and left. You can reflect a graph about the axes, so x and y axes, and you can stretch a graph out as well. So usually again in the X or Y direction. When you're investigating transformations, it is quite useful to use function notation. You'll notice I'm not saying transforming equations, or sometimes I say transforming graphs, but I'm now going to say transforming functions more often, because that's the right technical language to use here. And you're going to start to see the usefulness of function notation, because we've done function notation in lessons, but we haven't, it's kind of just been a process. And now I'm going to show you why it's potentially useful. So just as a side note, we're not going to come back to vectors probably in this topic, but it does appear later on. So I'm going to give you a quick recap, or maybe even an introduction if you haven't done it before. So when you're representing transformations, you can use vectors. So a vector is written just like you see on here. So it's x over y. X represents the left and right movement, and y represents the up and down movement. And you need to be careful not to confuse this with a fraction. So there should be no line separating the x and the y. It's not a fraction, it's a vector. Just as a couple of examples, so 3, 3, so that represents the x movement here. So if it's positive, it's what you would think it is. So positive is going to be moving to the right, and that 3 means it's moving 3 units up, so right and up. This one here, you can see -3 means it's going to move 3 units to the left, and this 2 is 2 units up. -4, -1, so that's the x value on the top. So that's 4 units to the left and 1 unit down. And then finally here, 13 units to the right and 2 units down. So we'll come across this later on, and you might see this in the worksheets as well. So just to recap, what are functions? So there's just a way of showing inputs and outputs, and a function is a set of instructions. So in this case, a set of instructions might be multiply something by 2. So whatever goes in, you multiply it by 2. Just again, you know this already. So x is what you're putting into the function. The f doesn't have to be an f. It could be any letter. It could even be a word, but typically it's just f of x. And then your output goes on the right. Now this, I want you to pause the video and have a go. This is just a quick recap of functions, and then I'm going to show you all of the answers in about 3 seconds. Okay, so here are the answers. So you put 3 into there, so you get 3 squared plus 1, which is 10. You put -2 into there, so you replace your x with -2, so that will be -2 squared plus 1, which is 5. Now, this case, you replace your x with 2x. So 2x squared, all squared, so it's actually 2x brackets squared, which then gives you 4x. 4x squared plus 1, and that's your answer. And then here, x plus 1. So you replace this x here with x plus 1 in brackets. So x plus 1 squared plus 1. And you'll see I've got the working out already here. So you should have got x plus 1 all squared plus 1, and then you expand, simplify, and you get your answer. And then the final question, f of a is 50. What is the value of a? Well, that just means you replace your x with a. So then you get a squared plus 1 is equal to 50. And then when you solve that, you can see, you can do that in your head. It's just going to be 7, sorry. A squared is 49, so a is 7. Okay, so that's a quick recap on functions. This exercise I'm going to expect you to do at the end of this video. So just a quick look at this. Is exercise 1. None of this is new, so it's just to recap. The answers are also provided on the worksheet. These questions here are optional. Again, they'll come with the answers on the worksheet. You don't have to do these ones, but you do have to do exercise 1 with working out shown. Now, function notation with graphs. So we can represent a graph in lots of different ways. And one of the ways you can represent it, a relationship between x and y, is just an equation. So you're familiar with that. Y is equal to x squared plus 4x plus 1. Another way to represent it is a list of ordered pairs, which is just a fancy way of saying coordinates. So they're called ordered pairs because the input is what you put into x and the y is what comes out. So if x is 3, you can then do 3 squared plus 4 times 3 plus 1, and then you'll get your y value. And you can list the coordinates just like this. So you got your x, y, they come as pairs together. You can list it as a table of values, so you know what this is. You're used to this when you're plotting graphs. You can actually plot the graph itself, so you can represent a graph on an axis. And finally, we're getting to this point here where we're going to be using the function notation. So you can represent a relationship between x and y as a function of x. So you can say f of x is equal to, and then this equation here is just the same as what you see above. And you may notice something kind of fairly obvious here is the y is equal to f of x. So it's another way of representing the y value in a function. So from now on, you're going to see y is equal to f of x, and f of x represents some equation. The y-axis can actually even be labeled as f of x, and you can represent it just as the way you can see below here. So here I said you can represent an equation as y equals f of x. The reason you might do that is because the equation of the graph itself might not be given. So you just have to represent a generic function. So here, let's say we don't know the equation of this function, and we don't. We can't write y is equal to x cubed plus 3x plus 1 because we don't know what the equation actually is. So instead, we can just write y equals f of x. And that's going to be acceptable from now because we're going to look at quite tricky graphs like this one here. And we can't really work out more about this graph unless we're given more information, but we're not ever going to need to do that at GCSE. So for this topic, you're just going to represent it as f of x. Just in case you're curious, this is the actual equation of the graph that you can see here. So it's a quartic, which means the highest power is 4. And then there's a little quadratic part to it as well, which is why it curves up like this. Okay, so just a few examples of equations and functions and showing graphs in lots of different ways. So here's an exponential graph, and you can write it as y equals 2 to the power x plus 1, which is what you're used to. You can write it as f of x equals 2x plus 1. This is technically more correct to write it that way mathematically. Or you could just write y equals f of x. There's another equation here. You can see it's a cubic graph given here. You can again represent it as, for example, g of x equals the same equation, or y is equal to g of x. And then you can do the same thing here, another quartic graph. And you can represent it maybe using the letter h. You can use any letter you want. Okay, so why do we use function notation? First of all, you can name individual functions to avoid confusion. So f of x and g of x, so it's easy to spot which function is which. It quickly identifies independent variables. So for example, if you're given an equation f of x equals x plus 2b plus c, those b's and the b and the c might confuse you. You think, well, do I substitute into that? Well, if you know it's f of x, it means you only replace this x, and the b and the c are just constants. Oh, and another example here, g of t is equal to t squared plus 4t plus a. It means you just ignore the a. There's nothing you can do with that unless you're given more specific instructions. And it quickly states which element of the function is to be examined. I'll show you what that means now. So here you can see 3 functions which have been plotted. And in this case, I've given you the graph. So I've been using Desmos. Shout out to Desmos for that. And you can see there are 3 quite long equations here. What we can do is just, instead of writing these equations out every time, we can just say f of x, g of x, and h of x, and we know what we're referring to. In this case, I've color-coded it, but you might need to write it out just once to be clear. And point 3 is it quickly states which element is to be examined. So an example of that is we can say find g of 3, which is this blue graph here, the cubic, rather than saying find the value of y when x is equal to 3 for the equation y is equal to x cubed minus 2x squared plus 4. So it's just shorthand, especially when you have lots of graphs to look at. Okay, so now I want you to complete exercise 1 and then move on to the next video after you've done exercise 1. And smash that like button. Whoever that one person is that's liking my videos, thank you. You know, it means a lot to me.